Astronomers point their instruments toward the deepest regions of the cosmos and compare what they see. The farther they look, the stranger the picture becomes. Some of the most distant galaxies are not merely far away. They appear to be separating from Earth at effective speeds greater than the speed of light. That should not happen. The speed of light is supposed to be one of the most reliable limits in physics. It is the boundary that keeps cause and effect intact, the line that impossible things are not supposed to cross. Yet the observations remain. On the charts, the gap keeps growing. The most distant galaxies appear to pull farther and farther away. Push the measurements far enough, and the numbers seem to cross a threshold they were never expected to reach. The immediate consequence is difficult to ignore. Either the measurements are misleading, or something that should be impossible is showing up in ordinary observations of the universe. A trusted rule suddenly looks less secure than it did before. And if relativity is still correct, then a more unsettling possibility begins to emerge. What exactly are astronomers looking at? The obvious explanation is a mistake. A telescope misread the signal. A calculation introduced an error. Somewhere in the chain of measurements, something went wrong. That would be reassuring, but the pattern refuses to stay isolated. Astronomers look deeper into space and find more of the same behavior. They compare observations gathered through different methods. They check again. Then they check again. Instead of disappearing, the contradiction spreads. The most distant galaxies are not the only problem. As observations reach farther and farther outward, more objects seem to cross the same forbidden line. On the maps, the effect does not shrink, it grows. That changes the situation immediately. An error can explain one result. It can explain a handful of results. It becomes much harder to use the same explanation when the pattern keeps appearing wherever the search expands. The correction never arrives. The expected failure never reveals itself. Each new observation removes another place for the mistake to hide. What first looked like an anomaly begins to look embedded in the universe itself. Not a single bad measurement, but a recurring feature showing up across enormous distances. At that point, the problem changes. The debate is no longer whether the observations are real. The observations are becoming increasingly difficult to dismiss. The problem is understanding what they mean. Because if the measurements are correct, then something fundamental appears to be happening, and it is no longer clear which rule is actually being broken. The simplest interpretation is also the most alarming. The numbers seem straightforward. The galaxies are getting farther away. Therefore, the galaxies themselves must be moving faster than light. For a time, that possibility hangs over the observations. But as cosmologists work through the problem, a different picture begins to emerge. The measurements do not necessarily require galaxies to break the speed limit. Instead, attention shifts to the distance itself. Astronomers stop focusing on the galaxies and start focusing on the gap itself. When the distance increases, what exactly is increasing? That subtle change matters, because if the speed limit applies only to motion through space, then an object can remain within the rules even while the distance between it and something else grows in a way that looks impossible at first glance. Suddenly, the contradiction starts to loosen. The observations remain. The distant galaxies still appear to outrun light. The measurements do not need to be discarded, yet relativity no longer seems doomed. For the first time, there appears to be a framework capable of keeping both pieces of the puzzle alive at the same time. The observations stay. The speed limit stays. The contradiction appears finished. The problem seems solved. Then a much stranger realization arrives. The crisis begins to look less like a violation of physics and more like a misunderstanding of what is actually moving. Which creates a new problem. If nothing is truly breaking the speed limit, then what exactly is increasing faster than light? The shift happens in a single assumption. Two galaxies become farther apart, so one of them must be traveling through space. That feels obvious. It is how distance works everywhere people look. Two cars separate because a car moves. Two airplanes separate because an airplane changes position. Growing distance and physical motion seem like the same thing. Then the cosmological picture forces a different interpretation. Astronomers look at those distant galaxies and realize the galaxies themselves are not necessarily racing through space at impossible speeds. Locally, the familiar speed limit remains intact. Yet the separation continues increasing. The gap keeps widening. The distance keeps accumulating. The measurements still show remote regions becoming farther apart faster than light could cross the space between them. And that is where the earlier belief breaks. The apparent violation was never hiding inside the galaxies. The galaxies were not the thing outrunning light. The increase was happening in the space between them. Suddenly, the observations stop looking like a rebellion against relativity and start looking like a misunderstanding of motion itself. A galaxy can remain within the rules. Another galaxy can remain within the rules. And the distance between them can still increase in a way that produces the astonishing numbers astronomers observe. The contradiction disappears. The mental picture does not. In some ways, the universe has become harder to imagine than before. Because increasing distance no longer guarantees that something is physically traveling through space. The old mental image collapses and a new one takes its place. The thing increasing faster than light is not a galaxy. It is the space separating galaxies. And once that possibility is accepted, an unsettling consequence immediately waits beyond it. What happens to the parts of the universe that are already being carried farther away than light can close the gap? The solution turns out to be real. Nothing actually had to break the speed limit, but the consequence is stranger than the original contradiction. Imagine a distant galaxy sending light toward Earth. The light leaves. It begins crossing the darkness between galaxies. The journey is underway. Then the gap keeps growing. The light continues moving forward, yet the intervening space continues increasing as well. For some distant regions, that increase becomes decisive. The signal is not blocked. No wall appears. Nothing destroys the light. The destination simply keeps retreating. Nothing disappears. Nothing is destroyed. The connection is what disappears. But contact is lost. Light emitted from those regions may never complete the journey. Not because the light stopped moving, because the destination never stopped retreating. And that changes what the discovery was really about. At first, the problem seemed to be a violation of physics. Galaxies appeared to outrun light. In the end, the speed limit survives. What changes instead is the meaning of distance. Entire regions of the universe can remain real while becoming permanently inaccessible. No larger telescope can recover them. No future technology can reopen the connection. The loss is built into the geometry of the universe itself. The distant galaxies do not have to disappear. They do not have to go anywhere. They only have to become unreachable. And that is the final realization. The discovery was never really about breaking the cosmic speed limit. It was about realizing that reality does not need to disappear to be lost. Parts of the universe can remain exactly where they are and still pass beyond contact forever.